morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our expert panel, The Hidden Costs of AI, Optimizing Your ML Data Stack for Production Scale, brought to you by our friends at Tecton. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI community. Today, we're excited to welcome hundreds of attendees from all over the world to discuss aligning your AI infrastructure and processes to maximize performance while controlling costs. The promise of AI at scale is undeniable, but hidden costs often undermine efficiency and ROI. From fragmented data pipelines to resource-intensive infrastructure, these unseen challenges can escalate expenses and delay production goals. Today, we'll discuss actionable strategies to optimize your ML data stack, ensuring streamlined workflows, efficient resource allocation, and long-term scalability. We're honored today to hear from a distinguished panel of experts. Kevin Stumpf, CTO and co-founder of Tecton, Susanna Kim, Director of Data Science at Mosaic Health, and Preeti Vaidya, Vice President of Analytics Solutions at Morgan Health at JP Morgan. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features throughout the webinar. We'll be addressing your questions throughout the webinar, so be sure to upvote the questions you'd like the panel to address. And finally, to learn more about how to optimize your ML data stack for production at scale, check out the call to action below throughout the webinar from our sponsor, Tecton. Now, without further ado, I'll welcome our panelists to the stage. Welcome, Susanna and Preeti, and there's Kevin as well. And Kevin. All right, so welcome to all of you, and we'll kick things off with some introductions. So I'll start with the order that you appear on my screen. So let's start with you, Susanna.
Oh, yes. Hi, I'm Susanna Kim. I'm the Director of Data Science over at Mosaic Health. It's a newly formed company that merges 4 entities in one, and my role over there will be to grow and expand the data science capabilities at this new company.
Excellent. Welcome, Susanna. Kevin?
Hello, I'm Kevin, co-founder CTO of Tecton. We work with a ton of different enterprises on real-time decisioning systems that use machine learning. Think about like fraud detection, recommendation systems, anything of the like. And been in the data and AI space for well over a decade now. Before starting Tecton over 6 years ago, I was part of the team at Uber that built Uber's central machine learning platform called Michelangelo that powers basically all of Uber's machine learning applications.
Excellent. Welcome, Kevin. And Preeti.
Hi, I'm Preeti. I'm a VP of Analytics Solutions at JP Morgan Chase. My background is in machine learning and computer science, and like Kevin, I also have a decade of experience in deploying advanced AI ML solutions across industries like engineering, media, and finance. My work focuses on creating scalable, innovative data strategies that then help address complex business challenges and drive operational efficiency. At JP Morgan Chase, I focus on healthcare innovation at Morgan Health. So now I'm doing healthcare. Morgan Health is a business unit with a really big mission of enhancing the US healthcare system. In 3 years, we've invested $210 million in 8 companies, including Mosaic Health, and work very closely with our benefits partners in improving the healthcare experience for our employees as well. Super excited to be a part of this really important conversation. Thank you for having me.
Fantastic. Welcome, Preeti. So we'll kick things off with our first question. At the initial experimental phase of AI and ML, things are simple. You have a database, a data warehouse, and just a few queries to write. But as organizations move into production and scale the use case, the data processing needs and the requirements start to compound. So can each of you share some of the problems that you've seen as ML teams go from notebook to deployment and face real world scale, often within very large enterprises? So we'll start in opposite order from how we did intros, and why don't we kick things off with you, Preeti?
Sure. I actually love how you've defined the problem, Brian, of going from notebook to deployment, because that's how it typically happens. You have this wonderful idea in a notebook, and then you need to have this big challenge of like scaling the solution. And I think the biggest challenge there is this like that I've observed is this lack of robust data infrastructure investment. That's just not something that can happen after you have like built your idea in a notebook. It's an upfront data investment that needs to support all of your use cases, a multitude of use cases, really, including experimentation in notebooks, as well as like mature data flows in production. Without this investment, everything will take longer, and you're really at the risk of losing your market, edge or differentiation. So, for example, you've built this really, really cool idea in a notebook, but if you can't scale it in a timely manner, you end up losing your edge. Somebody else will likely bring it to the market before you. The other bigger challenge, though, and I think I cannot emphasize this enough, is this lack of a data ecosystem. It's not just the infrastructure by itself. It's not just the teams developing solutions by themselves. It's everything. This is different from just this one component working in a silo, but then really how your organization thinks and operates with data. Includes everything from having the right teams defined, the right individuals, the right skills, best practices for data management, infrastructure, governance, quality, all of it. And we often hear like success stories of like teams that did it, that made it, and we don't talk enough about the ecosystem, the boring stuff that had to happen over years to make that glamorous product come to market. And I think having that infrastructure really helps unlock that ecosystem, really helps unlock innovation at scale, and really is a key differentiator in this day and age. So like start with the culture, start with the ecosystem first. Would be
Yeah,
like
excellent
my
point. Excellent
yeah.
point. Kevin?
Yeah, when I think about the general problems that occur as an organization scales up really their machine learning applications, their use cases, and go from just notebook to production, I think three different dimensions of scale are important to look at. One is people, like how many people do you have involved? Is it just one individual? Is it a group of people? Second is number of use cases. Are you just dealing with one use case or a multitude of multiple different use cases? And then third one is the scale of data. Do you just have tiny little data that fits in memory on a notebook, no issue, that it can easily process, or are you dealing with tons and tons of different amount of data? And I think thinking about those three different dimensions and which ones you need to scale up is helpful, because the problems you'll incur are different depending on which ones of those you're scaling up. Like if you're going from one person to 2 or 3 or 4 people who are all working on the same problem, then you typically deal with the issue of having to deal with handoffs and having more communication challenges, so that all the different folks are aligned and are working and collaborating well with each other. If you're dealing with scaling out multiple use cases, the challenges are typically that you will find that different teams work on different use cases, end up reinventing the wheel unnecessarily. Maybe it's they reinvent a feature pipeline that they shouldn't have, which now is completely redundant, costs a ton of money entirely unnecessarily. And then finally, as you scale out the amount of data that you're processing, the problems that you're running into can also be very different. Like if you're suddenly going, or if you're going from a machine learning application that maybe just processes, that maybe tries to detect fraud, and you're processing, 100 bank account deposits a day, to dealing with 100,000 transactions per second, the challenges on your data architecture and your systems are very, very, very different. Like you're not going to hammer your Snowflake with 100,000 queries per second, while it was definitely very tenable to send 100 queries to Snowflake per day.
Yeah, great points there, Kevin, about the unique challenges at scale. Susanna, what are your thoughts on this one?
So I wanted to start off like when you start, with just notebooks, all the time the data scientists are just kind of used to just experimental, like just doing whatever they want within their notebooks, kind of siloed on their own. But when you start moving over to production code, where you need to start like thinking about making your code more modular and thinking about breaking it down to little steps, if you're not transparent about that need, it gets a little difficult to get from experimental, just working kind of ad hoc, to building something that can be translated into like a production environment. So that's something I've noticed, that it's just good to be kind of transparent right off the bat. with your data scientist. The other is as you start scaling, kind of, what Kevin was talking about, like coordinating and talking about the resources. So like if you have a big job that you're kicking off and you kick it off in the middle of the day that kind of absorbs all the GPUs and CPUs, you're going to kind of affect the other teams that you're working with. So this kind of coordination and centralizing of your resources and kind of being mindful of, I'm going to need these resources then and that, we have to kind of share, and also thinking about like, if 4 teams are working on a code to kind of, um, you know, I don't know, what a use case would be like predicting if a claim would be adjudicated or not. I work in healthcare. If 4 different teams are working on that, that's a waste of resourcing when it could just work together. Like Kevin was saying, don't reinvent the wheel. Kind of figure out what you guys are doing, or do like transfer learnings to figure out, hey, this person has done this before. Maybe I can take some of the learnings instead of starting from scratch. Those are kind of the things I would think about when you're going from just kind of just like a small little team to something that's growing across the organization, where you have a whole enterprise data science group that uses large amounts of resources that are being shared across the organization.
Yeah, great point, Susanna. So from a big picture organizational perspective, what mistakes do you guys see AI and ML teams making in their workflows that end up driving up costs? Why don't we start with you on that one, Kevin?
For sure. Yeah, when I think about costs that are driven up from an organizational perspective, like ultimately the organizational costs are the people costs. Like how much are you spending as an organization on the people who are involved in developing and deploying your application? And those people costs, they're typically driven up unnecessarily when you see people just being idle a lot, and they're blocked a lot because they cannot get that work done independently. They have to rely on other people. Every time somebody relies on another person, on another team to get their job done, that always introduces a lag time and idle time, and ultimately drives up your personnel costs, because now you're paying folks for basically just sitting around and waiting until somebody else unblocks them. And the core reasons that I see that typically contribute to this is that you may have too much specialization early on. And if you have a ton of specialization, everybody can just do one thing, but you need 5 different things that in order to get your application developed and deployed. Well, now you need 5 different individuals or groups who all depend on each other. Which of course intuitively is much more expensive and much slower than if you have one person who can actually do it all. And so for instance, I oftentimes see companies who are able to move very quickly and very cost efficiently. They would specialize in hiring machine learning engineers who are just have the skills from data science to data engineering to software engineering, and can kind of just unblock themselves. But of course, that's not feasible for every organization. There's only so many ML engineers on the market too. And so at some point, you will have to hire folks of different skill sets. And what I typically see make the biggest difference there is if you can implement a lot of automation, like systems that ultimately allow your employees, your people to work in a self-serve way without having to wait for other people. And so that could be as simple as if somebody's working on a new feature or a new model, having automation in place that makes it as easy as possible for them to say, create a pull request, and then have that pull request kick off an automation pipeline that then maybe deploys that application to a staging environment without requiring the intervention of anybody else. And then before it gets promoted to production, the only intervention that's necessary is for somebody else to really deeply review the work and then hit the green button to launch this thing to production.
Yeah, very good points, Kevin. Susanna?
One of the biggest things that I've noticed is that you kind of over-engineer the problem or move too fast too quickly before verifying business impact. So there have been projects that, millions have been spent and there was actually no business value before they started like implementing it into production, moving it to downstream processes, and then realizing that there was no business, impact, no business value. All of that effort would have been wasted. So the resources to build a model, resources to move it into production, to get operations to get changed, doing all of that before, just start small, verify that there is a business value before, going to those big giant pieces and steps that, like making sure it works in the production environment, making sure that the downstream processes and operations are working. I would say that is probably the biggest cost, where you move too fast, too quickly before you realize there's even an ROI to it. Another thing would be too rigid of an infrastructure. So if you don't think about your design early on where your code is monolithic, you're not having modular containerized things, you do a quick update that destroys your models or the environment, or you want to switch out something small in your pipeline, but where to find it or where to do that, you really need to think about how you're structuring your code, how you're structuring um, to kind of prevent, updates or environmental changes or things like that would, you know, kind of break your code, your production environment, because that happens all the time. You really need to think about really protecting yourself as you move forward, especially as your organization gets bigger and bigger, as your data needs and the complexities of, like, you just update one library that could break all your code. Those are the kind of, in my opinion, very important things you need to really think about to kind of control for costs, because those could really compound and become much bigger problems as you scale up.
Yeah, great specifics there, Susanna. Preeti, what are your thoughts?
I actually completely agree with Susanna, and I'm actually going to pull the thread a little bit more and bring in the stakeholders and the clients and customers or end users into the picture as well. There's one thing that you're building something that is built right, but that definition of right is not always thought about until the very end, or when you're already halfway through ideating. Um, and I think the most important things that I've seen sort of be the differentiator between a really successful, well adopted product versus a product that sort of dwindled away a little bit was stakeholder, senior leader, and user buy-in from the very beginning. And successful projects have done this through like setting up some sort of a steering committee that then sort of meets on a regular cadence, talks about what is being discovered, clearly defines like the charter of like, what is this project going to do? What is the problem that it's solving? Is this the right problem to solve? Sort of validating that ROI, but before spending a lot of time actually trying to solve the problem. And really sort of getting that buy-in from the very beginning, building trust with your customers. And sometimes you might not have your end users, so doing like focus groups or things like that ahead of time to really understand the market that you're going to launch the product in. And this sort of goes hand in hand at the implementation side as well, similar to what like Kevin mentioned. Like there's a lot of dependencies across different teams. Every product, even if you start small in a startup, needs to scale at some point to meet the market share or market needs that you're aiming for. So what I've seen help is like the adoption of the agile framework or tracking like clear dependencies also, in obviously addition to automation where possible. But really thinking about like things that are worked in software development or other areas that could then help you in scaling up your work as well, either bringing someone to do product or if possible, obviously, or bringing the other skills that could then really streamline the operations. But keeping the stakeholders engaged and involved, I think, is key.
Okay, great points, Preeti. I want to get to one of the questions that we have in the chat from Tad. So can deploying customer-facing AI applications cause more harm than good if implemented before back-end data and API performance improvements are made? Anyone want to speak to specifically the customer-facing challenges? How is that distinct from some of the other challenges that we've already talked about? What are some of the special considerations you need to think about when scaling in a customer-facing context with respect to AI applications? Anyone want to take that one?
I can speak a little bit to it. I think there's this idea of like continuous improvement in software development, which I think is coming through the lens of like ML ops in machine learning and AI deployments as well. If you don't have the right infrastructure, if you don't have the right sort of ecosystem around your AI ML solution in place ahead of time, you run the risk of model data drift, your model not making sense for the application that you're trying to solve, amongst obviously other challenges. You're building the ship as you're sailing it. But depending on where your organization is in terms of like maturity, um, I think there's problems all the ways from like your model not working correctly, not having the right scale or the training data sets, all the way to like it's in production, but it doesn't make sense for the new data. It's sort of lost context because there's new data or some event happened that, like, for example, a new policy change and something happened that completely sort of threw off your model and you haven't put the scaffolding around it to do the right ML ops. Curious to hear what others have to say about this.
Um, to add a different point, it kind of depends. If the latency is really bad, people are just going to have a really hard time interacting with the customer facing things. So if the responses are really slow, or if it's just very buggy, or the answers are not correct, that's going to really cause more harm because it's going to kind of cause customer abrasion. So just keep that in mind. Of course, you don't need to have everything be perfect, but there's like a certain threshold where it's not annoying to the point where it would cause issues with your customers, and it has more value than harm. Then I guess you can kind of make that decision, and that's the point I would add.
Yeah, final thing from my side is the principle that comes to mind as an engineer is premature optimization. Like, you do want to avoid that and not too early on make the backend system, the API performance, etc., perfect, because maybe whatever you're implementing, whatever model you're implementing or decision system you're implementing actually just doesn't drive any bottom line impact. And maybe you can test that very quickly with a quick experiment where you actually are running pretty much a hack in production that's not super cost efficient or performant, but it gives you all the data that you need to decide on whether what you're experimenting right now is actually something worth truly scaling in production. And at that point, once you've got the data and once you've made the decision that this is something that you want to support going forward, you'd invest in really optimizing your backend.
Yeah, that's a great point, Kevin, and definitely in line with our topic today about how things can get costly if you don't watch out. So making sure there's a good business case and the use case actually is a valuable one before you're expending too many unnecessary resources on it. That tees up nicely for our next question, which relates to data processing. So in most production AI ML use cases, you'll have data processing needs that get computationally expensive as you scale. So what are some examples of data processing challenges that ML teams tend to run into? Why don't we start with Susanna on that one?
Some of the things I would come across with just the day-to-day is, like I said, siloed kind of data scientists working alone. So they'll kind of create duplicate data storages locally or in their virtual environments. So they'll kick off these expensive jobs to, create their own custom data sets. You want to try to, have a data set where it's kind of shared across multiple teams because they might be working on the same problem. They might be trying to build a model with the same data set. So trying to have like a centralized data storage for the data sets that are creating are really important. Some of the other things would be, it also gets kind of expensive over time. It's like manually kicking off building up your training sets or building up your data pipelines. So trying to automate that with maybe like an Airflow or another tool would be kind of important depending on, um, you know, what that data set looks like, because you might be building a model that's been in production for a while. So you want to start automating those pieces so like someone's not manually kicking off and refreshing the data set um, over and over again. And the other major thing would be trying to start from scratch all the time instead of kind of borrowing on what other people have done before or what has gone beforehand. So like not using any transfer learning or, building off of what was already there. And those would be kind of like the three kind of that I want to touch upon.
Yeah, great point, Susanna. Kevin?
I agree with those points. I would add, like, generally when I think about costs in data processing, I see them mostly be dominated by two things. One is just the compute cost of actually processing your data. And then second is the storage costs, but specifically only the storage costs really of fast databases, like in-memory databases that serve your data online in the production system. Offline storage this year, 2025, can almost entirely be ignored. Like, it's gotten so insanely cheap with the prices on S3 and whatnot falling down to near zero, that's not something that I ever really see dominate the costs of data processing. And so again, like the cost of data processing and of online storage are typically the dominating drivers of data processing costs. And if we want to drill into those a little bit more on the data processing side, you want to, of course, make sure that you're not processing data redundantly. And that goes back to what I mentioned earlier. If you have a data pipeline whose output can be shared by multiple different teams or use cases, you should absolutely do that because processing data can be extremely expensive if you're in a large scale environment that processes a ton of rows, a ton of unstructured data. Maybe you even use a model that processes the data. Maybe now with Gen AI, you even throw an LLM added, which makes the processing of the cost even more expensive, etc. So share as much as you can to get those costs down. Second, of course, adequate provisioning of your infrastructure is super important. If you provision a cluster that has a ton of memory but doesn't need that memory, well, now you're wasting the resources of idle memory. And so having someone truly look at, well, what's really in the right provisioning of CPUs and memory that I need to do this job well. And yeah, I think I can leave it at that.
Yeah, those are great points, Kevin. Preeti, what are your thoughts on this one?
I would say a couple of things. So completely agree with the sort of memory management aspect of this. With my computer science hat on, going deep into the code, I would say a lot of in-memory operations, or rather poor memory management, I think is the biggest impediment to scalability. Everything that is in memory starts adding up. So if you're creating data frame after data frame, like creating copies of it, even within like sort of your monolith code that you're building, that really gets computationally expensive, and to the point that you might not even be able to complete your experimentation, let alone like scale it up. The other one is, I would say, not understanding the tech stack or tooling available. So to Kevin's point, yes, you need to sort of provision the right infrastructure, the right cluster, the right number of nodes, all of that good stuff. But if your code is not written in an optimized manner to use those distributed resources, and you're still trying to like do everything in a monolith manner, still within the distributed environment, you're not going to reap the benefits of it. You won't, as you sort of scale up your data, you won't even be able to add 2 columns. So I think really understanding how the tech stack works, how the tooling works, could really help in writing really good code. The other sort of point that steps out a little bit from the code itself and sort of looks at like coordination across multiple teams is that oftentimes one team is sort of engineering the data, delivering it for use, or depending on how the organization is set up, someone is sort of writing your pipelines, doing some transformations for then you to sort of run the models on top of. Not having really good definitions, data dictionaries, data quality checks could then lead to a lot of like time spent really trying to go back and forth, building quality checks after, like as an afterthought. Having a lot of missing data could lead to your features not working, or your feature engineering to take much longer if you were counting on that feature. So I think that is often overlooked, but super important, having strong data quality framework, having really good sense of like data dictionaries, cataloging, understanding what your data can actually do and what it has upfront could help.
Yeah, those are great points, Preeti, as well. So I want to jump to a question that we have in the chat here from Craig, and it actually is a question we had on our list as well to address. Craig specifically mentioned he loved the point that Preeti made about having a clear perspective on business value before moving forward, moving toward full development and production of new ML-based capabilities. Can anyone share a story about business value unlocked with ML-based apps? And I would add to that the question that we had on our list, which is how do you, what metrics do you use to determine what success looks like for an AI or ML initiative? And that's particularly relevant to the cost question is, you've got to balance the cost with what success looks like and what the business value is that you're creating. So why don't we start on that one with Kevin?
Yeah, so when I think about specific anecdotes or metrics that I've seen move, where companies move their use case to machine learning rather than non-machine learning, the first set of use cases that always comes to mind is fraud detection. So when you look at the industry of companies who are doing fraud detection or general risk assessment, like you think about banks or fintech companies who are issuing credit cards or debit cards and who are deciding who should I even take on as a customer, who's worth the risk, and what transactions should I allow to be processed versus not allowed to be processed. Those types of decisions, when you look at the industry, companies split almost evenly in two buckets. There's the bucket of companies who use almost exclusively rules, like human hand implemented heuristics to make decisions. And the other 50% uses machine learning. And I've seen countless examples where companies told me that even their first prototype implementation of using machine learning to detect fraud or make a risk assessment decision moved the performance of their model by double-digit percentage points in comparison to the rule-based system. And double-digit percentage points in performance improvement for a fraud detection application could mean an absurd amount of money for the business. Back at Uber many years ago, a company was using, I think, pretty much literally millions a day to fraudulent end users. And so it can make a gigantic difference if you're able to detect 20% more fraudulent users or transactions than if you're not. So I think there was a second part to this question. How do you generally measure the impact? Is that right, Brian? Or what was the
That's
other?
right. Yeah. What metrics would be helpful in evaluating what success looks like?
Yeah, ultimately, it really depends on the use case. And like at the simplest level, everything should eventually affect your company's bottom line. Like what's the cost of the solution and what's the are you able to reduce the cost of the business, or are you able to increase revenue? That's the benefit. And then what's the cost of your solution? And ideally, the benefit way outweighs the cost. And for some use cases like fraud detection or recommendation systems, it's relatively speaking easy to identify the true bottom line impact. Now you still need to be smart using good data science tactics like using holdout groups and whatnot to truly identify the bottom line impact. But for those types of use cases, you can get a pretty good sense for, okay, how much more revenue how much more bottom line am I ultimately driving with this implementation? But other use cases can be fairly far removed from the bottom line impact, where you're just not going to be able to look at the balance sheet or the cash flow statement at the end of the month and determine whether it was actually moved by your ML model or not. Like if you think about machine learning models that affect how delighted a customer is to come to your website and to not use a competitor simply because they like the personalization a little bit better, or they like the AI generated welcome messages a little bit better. That's really hard to accurately assess, because oftentimes it'll take many months, if not even years, until you can truly measure whether this customer would have otherwise churned or wouldn't have churned, or how many more products they bought or didn't buy. And there, you can really just look at, oftentimes, just at proxies, like how is the customer satisfaction score, where I'm sending out surveys to my customers. Is that moving? Is that changing between the group that I'm exposing to this experiment, where their experience is driven by machine learning, versus the ones who are just seeing the old experience?
Yeah, those are great points, Kevin, about the difficulty at times of measuring those metrics. So very good points there. Preeti, what are your thoughts?
I'd say it really, really depends on, just to put it simply, what your use case is, what is the problem that you're trying to solve, and then sort of putting metrics around how well the solution solves the problem. So, for example, in healthcare right now, there's this big promise of AI in addressing physician burnout and streamlining administrative tasks. So, with GPT-like use cases becoming more mainstream, I would say measuring efficiency and productivity gains could be one way to track the success of the program. But really, it really depends on the problem. So in healthcare, if you're trying to solve the problem of addressing physician burnout, how many more, what is the quality of care that the physician is able to provide with your tool versus not? Asking the physician, while making sure that obviously the burden of using AI is not greater than the value that it offers, because then adoption and usage rates would drop for you. So those, I think, could be another metric. How well is the tool getting adopted? How often is it being used by the target audience once onboarded as well? And that sort of customer journey, that I think could also help.
Okay, great points, Preeti. Susanna?
So I actually, at my previous company, we actually did very robust program evaluations to evaluate how well our model was selecting the best members for our palliative care programs. So what we would do is we would use like propensity score matching to get like a one-to-one match from those members who were selected by the algorithm versus who were not, and then to measure out the difference in difference regressions and how much the cost savings we saved with the program. So we went very robust in trying to figure out what the dollar value savings are from the model that we use to find members for our program, and that they were the best fit and could give us, a large savings. And those evaluations would be actually shared with our clients, which would lead to, increased investments and good client-facing customers with showing the dollar value of our programs. So that's one of the anecdotes I have. Another would be for something for operations, where we had something called a digital nurse, which would help automate policy reviews on whether a procedure would be approved, kind of like to see if they were qualified for a pacemaker or a hip replacement. And so nurses would go in and review these documents manually, typically, to see if they fit the policy guidelines to be approved for that procedure. And that would actually save the operational efficiencies of the tool that we had, which would kind of automate and kind of go through these documents and claims and doctor's notes and clinical notes, it would automate that and we would save like, 20-30% of time on actual manual review. So these are the type of things that you would look for when you're deriving these metrics on what the value is of your program. So for certain things, it's dollar value, other things, it's operational value. It just depends on what the goals of your use cases, and you want to derive the metrics that correspond to what you're looking to save or improve upon.
Yeah, great point, Susanna. Really interesting use cases there in the healthcare industry. I want to jump onto something that we're seeing in the chat, kind of an ongoing discussion here. So Irfan first mentioned that he's curious to see the industry's view on notebook use in the production for data processing and pipeline. As a software engineer, I'm not used to this, but I can see some products that are pushing in this direction, like Azure Synapse and Databricks, et cetera. And then we had a response to that from Clark. So Clark says the flexibility of notebooks, for example, running cells in any order, leads to surprises when it comes to productionalize. They can be helpful to iterate on and test the logic, but good to develop each cell into a standalone testable function. So I wanted to get you guys' thoughts on that discussion, the use of notebooks and how that relates to the ability to scale things into production. Susanna, why don't you start with that one?
I don't think that notebooks are really good in production environments. You really just want, I think it's too much flexibility, and then you can't really modularize the code or it gets kind of messy. And then also with the flexibility, it's kind of just like you go cell by cell. If you want to update that or changing that, I think it would become kind of difficult. I personally believe that you want to have your code broken out into kind of pieces like this is for your data ingestion, this is for your feature engineering, this is a part for your scoring. And that really allows for you to be able to go and modify bits and pieces of code instead of kind of going through like a notebook or various notebooks to see where you might change your code in your production environment. So I don't think it's the best way for a production environment.
Great perspective. Kevin, what are your thoughts?
Yeah, I agree with that. I'm personally not a big believer in running notebooks in production. I think there are very few exceptions out there. I think Netflix is one of the companies that figured out a way to use them in some areas pretty well. But there's so much stuff that can go wrong when you try to put notebooks literally into production. That the simplest thing to think about that typically goes wrong is it's just hard to truly reproduce locally in your notebook environment what you will see later on in production due to the nature of notebooks. As was already mentioned, that you can execute cells in an arbitrary order, which will completely change the ultimate outcome. And that's something you really want to avoid, like the plague, that something that you see on your laptop at dev time differs from what you have in production. You want to have the reproducibility be near perfect, otherwise you will just be in a debugging nightmare. And however, notebooks are great for testing, iterating, experimenting. If it's even just one person who wants to run a quick experiment in production and nobody else is involved, nobody else needs to understand the notebook, it's fine. Throw it out into production to collect more data and to build up this conviction that that experiment you're working on is one that's worthwhile to put into production. And then when you put it into production, a scalable way that other people can contribute to, or that you properly want to monitor, scale up, etc. Then you want to take that code out of a notebook and then put it merge it into the rest of your production code base.
Yeah, great points. Preeti, your thoughts?
I think notebooks have a time and place. It's typically in the beginning, the ideation phase, where you're just trying to prove the concept out, narrow down the use case. It has its benefits. You can like quickly sort of build a graph or a chart and then view it and see sort of how it looks, get a quick insight out of a large volume of data, exploratory data analysis. I think that's where notebooks like really shine. But when you're really trying to get your solution into production, I don't think I agree with both Kevin and Susanna. Notebooks are not production use cases. what does make the journey from notebooks to deployment a bit easier is how you structure your notebooks, so having like annotation, clear headings, clear sections, Susanna was mentioning. What also helps is this thing called object calisthenics. It's like a set of 9 principles that describe how you should be writing your code. And if you can stick to that sort of those principles at the back of your mind, I'll drop the link in the chat. And as you develop in notebooks, I think that notebook then can become a good sort of foundation or backbone for moving into production. But if your notebook is just like willy-nilly, just throwing code and data and just changing things on the fly, then it's scrappy. It's not going to scale. It's not going to translate. You won't even be able to hand it over to someone else to scale it up for you if that's how you were structured. So I'll drop the link in the chat.
Great points, Preeti. I want to shift gears for a second and talk for a moment about infrastructure. So what steps can organizations take to ensure their infrastructure is aligned with long-term AI and ML production goals rather than just short-term experimentation needs? And how do you future-proof your architecture thinking ahead to future needs and use cases? Preeti, why don't you start with that one?
Sure. I think it's important to have a vision. That's how you can understand what you need from your infrastructure and then build the infrastructure to meet those needs. So if your needs are like rapid innovation, scaling up to petabyte scale, being able to analyze petabyte scale data, but then also handle multiple workloads of production use cases, if that is your goal, you should go back and balance that with what the reality is, building the infrastructure to meet those needs in the long term. But often where organizations or teams struggle is that your strategy is changing over time. You have vision, you have goals, but as you learn new things, it changes over time. Any good strategy does. So being nimble in making your strategy a living, breathing document and going back to it to make sure your infrastructure still meets your needs, I think that could be super helpful. The other thing that would be super helpful is to go back and check if your infrastructure is still meeting the state of the industry. So for example, if you have a use case that worked really well on this one technology that you had like 10 years ago, and you haven't gone back to see if there's something better in the market, you are obviously not going to get the benefit of meeting all of your use cases with your infrastructure. So building in that time of going back to the industry and seeing what is the state of the state, whether there's something better that can meet your needs, and thinking about how to scale up to that piece of infrastructure. If you have exponential growth in 2 years instead of 5, so that you're not struggling to scale up at that point, you can meet your customers where they are, you can meet your growth when it happens.
Yeah, great points, Preeti. Kevin?
Yeah, I would double down on that last point that Preeti made, which is seek inspiration from leaders in the industry, and those could be either leaders in the vertical in the space that you're working in. What are they doing that you can seek some inspiration from? Or if you're the leader in your industry, learn from other industries who are maybe further ahead and pushing the envelope a little bit more. Like you could, at the extreme, at the limit, always look at what's the tech industry doing and what are the Facebooks and the Netflixes of the world doing if you want to look all the way out there. Because generally, I think it's a good idea to try to steal well rather than innovate and invent poorly. And so there's a lot that you can learn from other folks. But beyond that, I mean, there's some, I think, rules of thumb where I think almost any organization now should have a good vision and a good implementation of a data warehouse, of a data lake. And if your organization has high real-time needs, there should be a good streaming infrastructure in place too, having a good data catalog in place, etc. Like there are some of those basics that almost any organization should have a vision for and implement.
Yeah, great points, Kevin. Susanna?
Oh yeah, just to add to that, you want to make sure that the long-term vision of what you need aligns with the short-term steps that you're taking to get to those long-term needs. And also to borrow from Kevin's point, you want to kind of go with what's the standard in the industry. So you want to try to do with modular design. You want to try to use your workflow into independent reusable components. You want to try to use containerizations. You kind of just want to try to be, you kind of want to use frameworks that are cloud agnostic or a specific platform agnostic. So you want to try to use like Airflows or Kubernetes versus, something that might be a SageMaker or something specific to a specific tool. That way, if you change your mind in the future, um, that's something that you can easily do without a lot of pain. So those are kind of the points I would add.
Yeah, great points all around. So the next question I want to get to is, as AI and ML rapidly evolve and production use cases are going to incorporate new technologies like agents, AI agents, as organizations adopt these new use cases, what potential cost implications do you see? So why don't we start with that one with Kevin?
Yeah, I mean, things are moving so quickly in the Gen AI space, but generally, I mean, with Gen AI models, like, ultimately you have to make a trade-off decision right now in your choice of a LLM and your choice of a Gen AI model, typically across like three main dimensions. One is the speed, second is the accuracy, or how good are the answers that you're getting, and then the third is the cost. And ultimately it comes down to your use case. Like what's the speed that you need? Would it be worth it for you to pay 10 times more money to get the answer twice as fast or not? Or do you need, does it really make sense for you to use a gigantic foundation model with 400 billion parameters? Or would it make more sense for your use case to use a distilled model, which can respond much faster and maybe not quite have the frontier level of performance, but is really good enough for your use case? And so really just comes down, what does your use case truly need? However, all of that said, optimizing the model choice, I think, is particularly important when you want to scale it out and when you want to put it into production. Before that, I would again go back to what I said earlier, avoid premature optimization. Like I would pretty much always by default start with like your 4.0 model from OpenAI. It's just a great generalist model, not super cheap, not super slow, pretty good answers come out of it. Build some experiments around that, and then you can optimize from there and see if a model from Anthropic or a Llama model or a DeepSeek model actually provides better bang for your buck. And so that's on the general decisioning around which model should you choose. And then second big one is, should you host your own model, or should you go with a provided model? Like you can host your own, like a Llama model or a DeepSeek model, either literally on your own servers, or you run it on Bedrock on AWS, or you go with a hosted provider like Anthropic and OpenAI. And of course, if you run it yourself, it comes with greater operational challenges where you need to pay, again, a human to actually deal with the maintenance of the system, versus if you just pay someone like an OpenAI or an Anthropic for the management, that could ultimately be significantly cheaper for you.
Yeah, great points, Kevin. Preeti, what are your thoughts on this one?
I think one thing that, as we are starting to talk about AI agents, obviously I'll go back to the very basics. Like think about what problem you're trying to solve before trying to solve it through a particular technology. But at the same time, with AI agents and the promise that they have, now you can build one without having to code. You can just write a few lines and it will do what you ask for it to do. Just because it can do that doesn't mean it needs to get done. You know what I mean? Like just because a task can be solved by an AI agent doesn't mean it's a task that needs to be solved. Um, So really going back to thinking about like, why are you doing this? Why are you trying to get an AI agent to solve this problem? And then also trying to coordinate, just like for anything else within your team, your organization, whether everyone is doing something and you're just creating like a proliferation of agents in your organization or your team, doing things in an uncoordinated manner with a lack of strategy will become like a short-term challenge, I think, which obviously like we'll address, and there will be best practices for that. And in the long term, as an industry or just generally, I think expert agents may become an opportunity area. So thinking about where expertise might be required and what a non sort of expert model could do as well. So planning your strategy around the availability of other advancements in the future in this space as well.
Yeah, great points, Preeti. Susanna, your thoughts on that one?
Yeah, just to add to it, I think it would just be too tempting to make too many custom solutions. So with Gen AI, you can kind of prompt engineer your chatbot to do a custom task. So I might get, really, it just might become too easy to kind of just create too many custom solutions for any number of ideas that you might have before really realizing the value or if it's even necessary, like Priti was saying. And also just if you do go that route where you're creating a custom AI bot for a specific solution, do you kind of just borrow from something that's already out there, or it wouldn't probably be necessary to just kind of build your own solution, like with like a DeepSeek or something like that, where it's something that could be more cost effective, where a lot of smaller companies might be able to build something in house. It might be not worth doing that when there's already APIs that you can connect to like ChatGPT, and it might just be easier just to pay for a solution or pay for those APIs instead of just going something custom or in-house. So those are the kind of thoughts I would think about.
Yeah, great points about buy versus build. So we've got about a minute left. I want to wrap up with our lightning round. So what would be your top piece of advice for organizations that are aiming to scale their AI and ML efforts while effectively controlling costs? We'll start with you on that one, Preeti.
How AI can help you unlock value instead of implementing AI first and then seeking value.
Great point. Susanna?
Recycle and reuse as much as you can. Don't try to reinvent the wheel. Try to keep reusing the wheels that you've already had to build your solutions.
Excellent point. Kevin, we'll give you the last word.
3 things: measure, standardize, and automate. Measure the costs, because you can't manage what you don't measure, and then standardize so folks in production aren't doing random different things. And then finally, if you've standardized things, you can layer in automation, which can help you control costs.
Yeah, great points all around, and it's been a great discussion. I want to thank all of you for joining us today. Really enjoyed the conversation. Great insights all around. So if you missed any of the webinar or want to rewatch anything, the recording will be available just a few minutes after the webinar ends. If you just refresh this page, we'll also send out an email tomorrow to all registrants with a link to the video on our YouTube channel. I want to say a special thank you again, both to our panelists and to our partners at Tekton for making this webinar possible. And we'll see you all again next time. Thank you.
Thank you.
Thank you. Bye.